Hi kids, this is the first video in the waves unit, properties. The essential question is, what is a wave and what properties do all waves share? A wave, put simply, is energy moving through space. So we've talked about energy before in previous units. A wave is just a little piece or a chunk or a pulse of energy that is moving through a material to get from one place to another. In that picture of a water wave below, you can kind of picture how the energy starts in the middle and it spreads out through the water. There's lots of different kinds of waves in the universe, but they have lots of things in common. They've got more in common than they have differences, even though those waves may appear to be very different. For starters, all waves have a wave source, which means that you can't have a wave unless something is jiggling or causing the beginning of that vibration. So that water wave, the wave source was that droplet of water. You could make a wave in a rope, but the source would be your arm. So there's got to be something starting the vibration for every wave. The second thing that all waves have is a medium. The word medium is defined as the material that the wave is moving in. So for a water wave, the medium would be the water. In that picture shown on this screen, the medium would be the rope that the material, that's the material that the wave is in. A third thing that all waves have in common is a property called amplitude. The amplitude is the amount of energy in the wave. So when you give the wave a lot of energy, it has a lot of amplitude, and when you make a very gentle wave, it doesn't have very much amplitude. For example, in that rope wave you can see in the picture, the amplitude is shown by the height of the wave, because the more energy that she puts into it, the higher the wave will be. One minor difference between some types of waves is called the propagation type. So all waves kind of jiggle, but that jiggle can be up and down, side to side, or in and out. So the way that the wave moves compared to the way that the medium moves is called the wave propagation type. There are lots of wave propagation types, but the two that we're going to be dealing with mostly in this class are called the transverse wave and the longitudinal wave. In a transverse wave, if you follow one little piece of that slinky, for example, it moves up and down when the wave goes past it from left to right. Another way to describe that mathematically would be the medium vibrates perpendicular to the wave velocity. The second kind of wave shown there in the animation is called the longitudinal wave. In a longitudinal wave, the medium vibrates left and right. At the same time, the wave moves to the right, so we would say the medium is vibrating parallel to the wave velocity. There are several other kinds of waves in the universe. Rayleigh waves are circular kinds of waves. There's torsional waves, etc. But the two that we're going to be dealing with are shown above. A few pieces of vocabulary that you should be familiar with for waves. The first is crest. The crest is the highest point of the wave. So if you look at that picture of the wave below, you'll notice the crests are labeled. They're the tops of those waves. And the bottom of the wave is known as the trough, also a word for kind of a bucket that an animal or something drinks out of. So you can imagine the troughs looking a little bit like buckets. Incidentally, if we're talking about the longitudinal wave, instead of being the top and the bottom, because those kinds of waves don't have tops and bottoms, we would talk about the highest pressure spot, where the material or the medium is compressed the most, compared to the trough would be the lowest pressure point. Amplitude, which I mentioned a little bit earlier, can also be defined as the height of the wave measured from equilibrium. So if you picture that wave below as a string, equilibrium would be that flat string shown by the black line in the middle. So the amplitude is measured from that equilibrium, so just from the middle up or from the middle down, and the amplitude, again, describes the amount of energy in each wave. The last vocabulary word I want you to be aware of is a cycle, so I may talk about wave cycles. A wave cycle includes one complete wave, which means one full crest and one full trough. So the length of a cycle is up and then all the way back down again and then all the way back to the middle. Alright, so that was a quick introduction to waves and some of the vocabulary words that we'll be using in class. Take a minute to revisit the essential question, which is what is a wave and what properties do all waves share? Thanks for watching.